Hello sir, good morning. My name is Rehan Mokashi from TY IoT and serial number is 22. Today we are going to discuss what is transportation model role, and in that first we see northwest corner method. So first we will see what is transportation model. If there are some factories in different cities and they wants to supply the product to other cities. So here is a mathematical table. So here you can see there is a distribution center and demand center. Actually, what is the demand? Here is a plant 1, 2, 3. So you can consider first plant in Mumbai, another plant in second plant is in Delhi, and third plant in Chennai. And here is the supply. Supply you can consider 100 units from Mumbai and 200 for Delhi and 300 for Chennai. These are the units which we want to supply. So we are producing in this Mumbai, Delhi and Chennai. And in below that there is a demand. So demand is like B1, B2, B3 and B4. What is the demand of Mumbai? City 1, City 2, that like. In some cities there is a manufacturing unit and we have to supply that product from manufacturing unit to throughout the unit, throughout the country. And this X11, X22, there is a sample costs I have taken for the explanation of the concept. Today we are going to discuss one transportation problem, which method is northwest corner rule method. By using this method we are going to solve the transportation problem. Here are many methods to solve the transportation problem. The first one is a row minima method, column minima method, and list cost minima method, and penalty method. In between that, another method is a northwest corner rule method. So we are using this method and we are going to solve this problem. So here is a problem. The problem is obtain the initial basic feasible solution of the transportation problem whose cost and requirement table is given below. So here you can see the cost for the transportation. Here we have considered one organization, and this organization want to supply product by using that cost. So which is the cost? Here you can see organizations: organization 1, organization 2, organization 3 and organization 4. For that organization, here is a demand. So organization 1 want 2 cost to supply the product to D1. So here is a 2 is a transportation cost. For that organization 3 want to supply product to D2. They want 4 is a transportation cost. So here is a transportation cost. So for that we have to find initial basic feasible solution. So here we are going to solve step by step how we are finding the initial basic feasible solution. In that, the first step is we have to find this matrix is balanced or not. How we'll check this matrix is balanced or not? For that, here is a 2 separate column is there and 2 separate row is there. So first column is supply column is extra in that and here is a demand row is separate. So this supply and demand total cost is equal. Means here you can see what is the first step. Calculate the total supply and total demand to check the table given balanced or not. So supply values are 5, 8, 7, 14 is equal to 34 and demand costs are 7, 9, 18 is equal to 34. Means both supply and demand are equal. So this matrix is a balanced. Now we are starting to obtain the initial basic feasible solution. So for that we have to assign the direction for the table. Here is a direction I have already assigned. So at the top side you can see here is a north direction, here is a south, here is a west and here is a east. So the method name is northwest corner rule. Means we have to start from northwest corner. So here is the first value is a 2. For that 2 we have to assign values and check for the what is the initial basic feasible solution. Like that, for one by one we are solving this. First northwest corner side cost is a 2. For the 2 we have to assign the one value. Which value we checking in both supply and demand. In that supply and demand, which is the minimum value, we are going to assign this value to that 2. So in that supply there is a 5 and in that demand there is a 7. So in between that minimum value is a 5. So we are going to assign 5 to that 2. Already I have assigned. Then we have to subtract this 5 into that both supply and demand. So when we supply the 5 into that 5, then remaining value is a 0, and 5 into that 7, then remaining value is a 2. So for that remaining supply is a 0. So for that organization 1, remaining supply is a 0. So we are going to scratch this line because there is a 0 supply, so we are not able to fulfill this 2. So there is a 0. Then again we are checking to which is the northwest corner side cost. So there is a 3 is a northwest corner side, so we are considering this 3 and we have to assign for that 3. So for that we are checking in both supply and demand. So in between that which one is the minimum value? So there is a 2 is a minimum value for that 3. So we are going to assign that 2 to that 3. So here I have assigned that 2 and I want to subtract that 2 into that 8 and into that 2. So 2 minus 2 there is a 0, remaining demand is a 0, and here is a remaining demand is a 6. So for that organizations there is a D1, for that D1 there is a 0 demand is there. So we can't provide that 5 and organization 3 and 4 to demand, so there is a 0 demand, so we are going to scratch this line. Then next northwest corner side cost is a 3. For that 3 we are checking in that both. So which one is the minimum in that supply and demand? So there is a 6 is a minimum, so we are going to assign this 6 to that 3. When we assign that 6 to the 3, then we have to subtract from that 9 also and from 6 also. And when we subtract that 6 into 6, 6 minus 6, then remaining cost is a 0, means remaining supply is a 0, and here is a remaining demand is a 3. So here I am going to subtract that remaining is a 3 and here is a remaining is a 0. So I am going to scratch this line because there is a no supply, no. So I am going to scratch this line. So next northwest corner side cost is a there is a 4. For that 4 there is a 2 values 7 and 3. In between that minimum value is a 3. So I am going to assign that 3 to that 4. So I have assigned now I am going to subtract that 3 into that both supply and demand. So when I subtract from that, there is a remaining is a 0 and here is a 4. So here is a demand is 0, so we can't provide organization 4 to that any demand. So I am going to scratch this column. Okay. Next next northwest corner side cost is a 7. For that 7, supply is a 4 and demand is a 18. So in between that minimum value is a 4. So I am going to assign 4 to that 7. Okay. Then I am going to subtract that 4 into that 4. So remaining supply is a 0 and here is a remaining demand is a 14. So here is a total supply is a 0 for that row. So organization 3 can't provide any other to that product, so I am going to scratch this row. And next cost is a 2. For the 2, that supply is a 14 and demand is also 14, and I am going to assign that you can assign any other value, means in between that any value to that 2. So I am going to assign 14 to that 2. So here is the remaining supply is 0 and remaining demand is also 0. Now the last step is we have to find the initial basic feasible solution. So here are the assignments which we have assigned. For that 2 we have assigned 5. For that 3 we have assigned 2. For that 3 we have assigned 6. For that 4 we have assigned 3. And for that 7 we have to assign 4. And for that 2 we have already assigned 14. So we have to find initial basic feasible solution by using this assignment. So here you can see what I have did. So here I have to multiply 5 into 2, 3 into 2, 3 into 6, 4 into 3, 7 into 4 and 2 into 14. So the transportation cost is a total 102. So the total transportation cost is 102 for that transportation matrix. So total transportation cost is a 102. And here is also initial basic feasible solution.